Hello everyone and Assalamu alaikum. I'm Zainab and I would like to welcome you all on behalf of DICE Analytics to the round 6 of DICE Webinar League 2021, Dive Deep into Deep Learning and AI. I'm glad to introduce our speaker today, Mr. Albab Khan, who not only happens to be an efficient deep learning engineer, but also leading deep learning for AI training at DICE Analytics. His key expertise are in the domain of machine learning, deep learning, data mining, data-driven marketing, and data prediction. In today's session, you will be exploring all about deep learning, its tools and technologies, its applications, the exact difference between data science and deep learning. You will also be guided about the career path associated with it and why you should go for it. It's a request to all the attendees to note your questions during the session and ask your queries in the Q&A session at the end. Thank you so much. Over to Mr. Albab.
Thank you so much, Zainab, for such a good introduction. Uh, Hello, everybody. My name is Albab Ahmed Khan. I'll briefly introduce myself in the when I'll be sharing the slides. But before that, I would like to engage some of the participants. First of all, to introduce yourselves. So we'll be starting with Amir Jan. Amir, can you please tell us what your background is, what's your expectation with this webinar, and just a brief introduction about yourself. Yeah, Amir.
Albab, you have to allow the participants to
Yeah.
talk.
So
Okay.
Amir, can you please unmute, please? Okay, I guess he's unavailable. So we'll be moving to Adarsh V. Kumar. So Adarsh, can you please tell us a little bit about yourself and your background and your expectation from this webinar? Yeah. Adarsh, we are not able to hear you. So Adarsh, we are not able to hear you. So we'll be quickly moving to Adrian Sharman. Adrian, can you please tell us about
Yes,
yourself?
yes.
Yeah.
Good morning, good day, everybody. Adrian Sharman here, joining from Cambridge in the UK. Just to see if we can learn a bit more on deep learning and how it pertains to the larger subject of AI. So, and quite an international event, and I thought it'd be fun to attend on a Saturday.
Thank you so much for joining, Adrian. Let's move to the next participant, Akib Javed. Can you please tell us about yourself and your expectation from the webinar? Yeah, yeah, Akib.
Yeah, Hello everyone. My name is Akib, and I'm a student from Zabist. I'm having a master degree from Zabist in data sciences, and I would like to have um, a more experienced. Uh, mm, I mean to say a more experienced person to tell me that how it is important to for a data scientist to learn deep learning and that stuff, because machine learning is quite a not that difficult, but deep learning is a difficult thing to do, as there's a lot of algorithms and things. Yeah, that's it.
Yeah, thank you so much, Akib. Thanks. Let's move to the next participant, Burhan Rais. Can you please tell us about yourself, about your expectation from the webinar,
Sure,
and a little bit
Albab.
about your background as well?
Sure, definitely. So, Albab, I have a gross experience of more than 10 years now. So, I started my career with Wipro. Over there, I was working into SAS programming. Working there for like 4-ish years, I moved into EXL analytics. Over there, I was working on the statistics side as well. So, after
Great.
working for 1-ish year, I moved to Moody's Analytics. Moody's, I was working for like 3.5 years. Over there, I was working on, apart from SAS and analytics stuff, I was also working into a backend development of a tool. That backend development was in Python. And then I moved to Dubai. Over there, I was working in data quality for an year. And now I'm working with Capco Consulting in Gurgaon. So over here, I'm having a techno-functional role. I'm working on SAS programming. I'm working on analytics, and I'm working on a bit of Python as well.
All right, all right.
So, yeah, so it's a techno-functional role. Business and I mean a BA role, which actually requires me to be involved functionally and technically as well.
Okay. So what are your expectations from the webinar?
Albab, what I think is I just want to grow myself as a professional. Since I have already moved my career towards the BA role, I just want to have a better understanding on machine learning. I mean, I know I've worked a bit on machine learning, but on the deep learning side, I just want to excel myself. So that is the expectation I'm having.
Okay, thank you so much, Burhan. Thanks for your time. Definitely we'll be digging deep into the deep learning concepts today, and we'll be discussing the major differences between both of machine learning and deep learning, and what are the
Mhm.
areas to explore in deep learning as well. So that would be a good talk today.
Okay.
Moving to Ali Hassan. Hi, Ali, how are you? Ali, can you hear us? I guess Ali is unavailable. Faizanur Rahman, can you please introduce yourself and your expectations from the webinar? Faizan or Ali, either one of you, if you guys are available, so we can have a discussion on that. Okay, let's move to the next participant. So, Ashwini, are you with us? Ashwini, can you please turn on your mic so that we can have a introduction of yours? Yeah. Hi, Ashwini.
Hi. Hi, this is Ashwini. Yeah, I'm here.
So, Ashwini, what are your expectations from the course, from this webinar, and what's your background? And can you please tell us about yourself?
Hi. I'm a startup founder actually. So
All right.
what I would like to understand is I'm developing a SaaS platform in the financial services. So I'm interested in learning more about art. I know the basics obviously, but I'm interested in learning more about, artificial intelligence and deep tech, because I'm planning to integrate that into my platform. I'm otherwise a financial person,
Okay,
so
okay,
I
okay.
don't have a technology background per se, but I just
All
want
right,
to
all
know the
right.
basics.
Yeah, that's good. That's good. Yeah, Ashwini, definitely will be covering most of the things what you expect from this webinar, and it will be very exciting for I guess everybody. Moving to the next participant, Arsalan Munir, can you please turn on your mic so that we can have a conversation with you? Hi, Arslan.
Hi, hi Albab, how are you?
I'm good. I'm good, Arslan. So, Arslan, can you please tell us about yourself? From what background are you, and what are your expectations from uh, this webinar?
I'm a software engineer currently doing a job in a private organization, and
Okay.
I expect from this our webinar that we will have some idea about how the AI works and what about and the applications of the artificial intelligence and deep learning.
All right, all right. All right, guys. So basically, we have the list is quite very long right now, so it won't be possible for us to have the brief introduction of everybody. But I must say that we have a diverse set of participants, attendees who are attending this course, this webinar. So that's really impressive and really exciting. So I'll be quickly sharing my screen. So please let me know if you can see my screen, guys. Meanwhile, you guys can mute yourselves. Okay. All right, guys. Can you guys see my screen?
Yeah, it's visible.
It's all good.
Okay. So guys, if you guys have any questions, so you can just type it in the chat box. So after covering some of the part of the slide deck, so I'll be briefly moving to the chat and I'll be answering your questions. Starting the webinar, uh, I'm a part of Dice Analytics. So this webinar is conducted by Dice. Dice Analytics has a set of 7 major seminars. So basically, they were started back in 12th of January. So this is the 6th webinar of Dice Analytics. The first webinar was related to Microsoft Excel, where we enabled our participants to get some analytics out of Excel. Then in the second webinar, we were having Rosari. So basically, text mining use cases through NIME were discussed in that particular seminar for like 2 hours, and that was a very exciting webinar. After that, Wakas Harshad were with us, who guided everybody to the major concepts of data warehousing and BI and the analytics on the top of all of those data warehousing and BI concepts. That was another very nice webinar to attend. After that, data science webinar was conducted by Mr. Zubair. He is from Jazz at the moment. In that particular webinar, most of the guys, if you have joined that, so you might have some idea which was delivered in that webinar about data sciences and machine learning and the basic stuff which is being done in these days in the industry as well as academia. After that, big data seminar was there, which was conducted on 23rd of January. It was round 4 of big data, and in that particular webinar, we had some good concepts of mostly big data tools and in the platforms which are top notch in the industry these days. Right after that, webinar number 5, which was related to DevOps, was conducted by Ali Kahoot. So it was another very very challenging and very exciting webinar to attend. And right now, you guys are with me in deep learning for AI and webinar, where we were discussing the differences between the machine learning, conventional machine learning, and deep learning, and all of the stuff which is included in AI. So after that, we have another round of webinar, which is 7th webinar, and it will be conducted by Ali Raza Anjum. It will be basically no coding webinar, where those people can join and those people can learn all the ML and all the data science part, which they don't want to do in the conventional coding practices. So using any code, they can move to the ML or move their platforms to ML or DL by using NIME. So this was a brief introduction about all the series of webinars which have been conducting before me and after me. So here we will be having 2 hours of discussion, where we'll be diving deep into deep learning and AI. We'll be majorly discussing the differences between machine learning, deep learning, what are the applications of deep learning, in which particular application, what sort of models or algorithms are being used, and how they are utilizing they are being utilized in the industry. So talking briefly about my experiences and my introduction, my full name is Albab Ahmed Khan. I belong to Pakistan, Islamabad. I have been working in various organizations such as Inbox, starting my career from Inbox Business Technologies in Islamabad. Then I shifted myself to Telenor, Pakistan, and then currently at the moment I am in Zong, China Mobile Company, where I'm working in customer value management as well as leading data science team. So basically, implementing end-to-end algorithms and the implementation of those models in the different applications or different campaigns. So apart from that, I am also associated with Dice Analytics, where we are focusing the knowledge transfer to the people who want to join that particular field, where they want to join whether deep learning or data sciences, or they want to integrate their current systems into with the help of these ML and DL algorithms. So moving to the next part. So let's formally start. Before diving deep into the deep learning, let's first talk about what data science is. So actually, most of you guys would already know. Some of the people who are not from the background of data sciences or machine learning, I would quickly go through the major concepts what data science is. So basically, it's a combination of three main tasks. One of them is domain knowledge, like whatever. Right now, I am, for example, in a telecom company or a telecom organization. So my domain knowledge would be based on all the information from the telecom industry. So if we have another person coming from consumer level organization, so he would be having some different set of domain knowledge. So the domain knowledge varies from field to field, and it varies from industry to industry. So uh, apart from that, the second main pillar for data science is mathematics and statistics. As we were discussing with most of our participants, so some of them were telling me about the introduction of theirs while they have some background of statistics, and they are working in some of the organizations where they usually use maths or mathematical equations or mathematical formulas, as well as some statistical inferences. So that is that is a key, and that's the uh, main pillar for data sciences as well. And the third part is computer sciences. So you need to know the technology, and you need to know the uh, design technology for that, for all of this whole platform. Whether you need to know the code, you need to know the right tools which will help you in order to implement all of your ideas and all of your mathematical and statistical knowledges with the help of the domain knowledge to to any sort of problem. So in order to extract the insights and in order to extract the knowledge from the data, you need to have these three main these three main, you should be the champion of all of these. So if we combine computer sciences and maths, so the two bars of the equation, so basically the yellow one and the green one, if we combine both of them, so having the skill to implement any algorithm or implement any equation into a code, and on the other hand, having the good information and good knowledge about the mathematical or statistical equation, if we combine both of these skills, so machine learning comes into existence. So machine learning is simply you know, or you are very good at coding any mathematical equation and giving the data to that equation. All right, and machine can learn that by that code of yours. But if I join computer sciences, yeah, or you can say programming skills along with your domain knowledge, by combining both of them, another new field comes into existence, and that is, you can say, it's a conventional software development. So conventional software development always arises or always occurs whenever there is a problem, and you just make a solution for that. For example, I'm in a grocery store. I need to boost up my sales. So what I can do is that I can go on the uh, web, and I can make a website out of it. That's a conventional machine software programming. So that's a example of computer sciences and combination of computer science and domain knowledge. Apart from that, when we combine domain knowledge and mathematical or statistical part, so combining both of them will give you a knowledge about the conventional research what you are doing right now. So whenever there is a task and whenever you have to make any research, so what you do is that you get the good knowledge of your data, you get the good knowledge of the domain in which you are working, and then you look for all the mathematical algorithms and all the equations which were already satisfying the solution, which were already giving you somewhat some baseline model or stuff like that. So that's an other field. So combining these new three fields, one of them is conventional research, the other one is software development, and the third one is machine learning. But when we combine all of them, so a new field comes into existence, and that is data sciences. So basically, data science is the combination of all these three interdisciplinary fields of the scientific methods. So let me see, we have some questions here. Okay. Move forward. Okay, coming to the whole overview of the structure in data sciences and machine learning. First of all, there are two main steps. One of them is, first of all, I'll go through the first step. The first step is defined by, it's defined by a process. There, whenever you are targeting any process in data sciences or machine learning or deep learning, it always arises with the help of an example, with the help of a problem. So for example, there's a problem that you have to decide that, okay, in your area, there is a match going on, and between team A and team B, who will win the match? So that's a problem for you. Now you have to solve that particular problem with the help of any mathematical equation or any statistical insight that, okay, whether this team or team A would win because of a particular player. Similarly, team B would win because of a particular player, or whatever the condition is. That will depend upon the amount of data and the amount of knowledge we have at the moment. So the problem arises, and what we do is that we start acquiring all the required data for that particular problem. That the acquired data will help us to, in order to tweak the problem into multiple disciplines. For example, first of all, today we are targeting problem, such a problem where team A or team B, we need to decide between both of them. But for example, in the future, if we need to have a difference between, or target a problem where we are going to identify whether team C or team D, who will win between both of them. So in order to get that data again, we need to acquire lots and lots of data against all the problems. For example, if team A or team B, we need to see that, okay, who will win the match between team A and team B. So what I would need is that I would need to know all the required data of the players, of the ground, of the empires, of basically everybody associated with team A and team B. All right. When I'm done with that, and when I'm done with acquiring all the required data of team A, B, C, and D, all of them, I need to ingest or ETL that data. I need to ingest that data into my small data warehouse, where I need to shift that big amount of data and filter out the desired KPIs, or filter out the desired number of attributes to solve my problem. Right after that, once I'm done with that, I am on the step number 3, where I have extracted all the required data to solve my problem, what I think is the best. Here, what I can do is that I will start a process named as EDA. So EDA is exploratory data analysis. In the layman words, you can say that you need to see that what are the columns which are important, what are not. What columns are there which help us to identify that, okay, team A would win or team B would win. It's, you can say in layman terms, you can say that you can simply differentiate between both of the classes or both of the groups. Based on that, we can make some interesting visualizations to solve that particular problem. So this is the ongoing process. This, you can see the arrow is going right and the arrow is going left as well. Because based on that, when you wrangle the data or when you manipulate that data, you clean that data up. Maybe it can give some interesting insight which you were expecting, and maybe it can contradict to those insights which you were expecting or which you were having some hypothesis. It happens haphazardly, and it happens again and again. So basically, this is an ongoing process which goes again and again. So basically, you visualize all of that data, you wrangle the data again, you again visualize that, you try to make some insights and make some analytical information or analytical insight from that data, and then you again go and wrangle that data. Once you are done with this process number 4 and process number 5, when you're done with both of these steps, so now you know precisely that, okay, these are the set of attributes or these are the set of columns which are most likely going to help me out to solve my problem. Okay, now for example, out of those 200 or 100 columns or variables, or it can be anything, based on that, if you decide that, okay, these are the 10 or 20 attributes are there which can help me out, so then comes the next process, and the next process is modeling part. Okay, first of all, we'll cover the classical machine learning part, and then we'll cover that, okay, how deep learning will come into existence and how that will replace the machine learning engine. So in that particular situation, what you do is that you choose a particular model and you choose a particular set of data. That data would come right from the EDA part right over here. When the EDA is done and columns are selected or attributes are selected, those attributes, columns, or KPIs, whatever you can say, those will go into this particular model and you will train that particular model. So that training that particular model seems very easy, but it's a whole world in it. So you need to be very precise about the hyperparameters. You need to be very precise about the uh, building and training of that model, that, okay, how that model is being trained, whether it's making some mistakes or it's going very towards very perfect line, or you need to take care of all of those criteria. Once that is done, you have trained a model and you are somewhere sold that, okay, this is a model and these are the set of uh, columns on the base of which I decided a model, I trained a model. Now I am accepting the results, what this model is giving. So there comes a performance criteria. That performance criteria would vary from problem to problem and case to case. For example, if I am only deciding between team A or team B, so the performance criteria would be something different. Uh, let's say that can be an accuracy, or that can be a precision or recall. I'll briefly tell you about all these terms, what they say. But if I am trying to solve another problem where I'm trying to identify some unique groups out of the data, so the right over here, the performance criteria would be somewhat different as compared to the previous problem. So that varies from problem to problem. But let's just say, for the sake of an argument, we say that, okay, we are accepting the results, that, okay, we made a model and that's very accurate. For example, let's just say that's like reasonably accurate around 85%. We'll go with that. After that process, we validate that data. That data is being validated by a set which is uh, put aside, and we don't display that set to our model which was being trained. First place, we got some accuracy, the training set, and now we get some accuracy or validation at the validation set, or you can say testing set. Now, once the validation is done, so we'll briefly see the results, whether they are actually solving the problem or not. If they're not solving, we'll go back. We'll train the model again, we'll select the model again, we'll look into the attributes again. So that's again an ongoing process. So model will be chosen, it will be trained, it will be validated. If results are not good, again model will be chosen, variables will be chosen, and data will be chosen. Again model will be trained, again it will be validated. So it's an ongoing process again and again, until unless you are dead sure about the results, that, okay, these are the results, training accuracy was that, validation accuracy was that now I'm done with both of them and I can move forward. So then we move forward to the deployment part. So deployment, most of the guys would already know that deployment is basically whatever the model you have made to solve a problem, you'll integrate that with the running system. The data would come into your model. It will generate some insights. It will generate some values, which will be again written into your already established systems. And then it will give you some powerful insights, and it will help the business or the decision makers. Right after that, when the deployment is done, after some time, we'll again do a testing. So most of the guys over here would be confused about this last step, that okay, if we had a validation over here, why we need this testing set? So that's a real-time testing. Real-time testing means that, for example, I have a problem, and the problem is to identify uh, any potential threat entering into my city. Once I make a model, I identify all of the cars or all of the people sitting in those cars by looking into the facial expressions of those people, by looking into the uh, driving sense of the driver, or by looking into the condition of the car or the number plate or stuff like that. And based on that, I make a model. I validate that model and I deploy that model on the CCTV cameras or HDR cameras uh, in the entrance, on the entrance, as well as the exit points of my city. After some time, I need a valid testing for that. Why I need a valid testing? For example, uh, I trained the particular model uh, on, for example, October 2019 to identify potential threat. Maybe that potential threat would have some features. For example, that potential threat would have a very old car. That potential threat would have no number plate on the car, or that potential threat would be very confused while entering my city. Or you can say, based on the emotions and based on the expressions of that particular person, I can identify whether he is a potential threat or is a normal person. So if he's a normal person, good to go. Is a potential threat, just keep it. Just try to generate an alert in the model. Once we have deployed that model, and after 1 year, evolution comes. And what if there is another potential threat coming into my city after 1 year, and maybe he can be in Rolls Royce, maybe he can be very suited with it, or maybe he can be having a golden number plate. So we cannot establish the relationship between a potential threat and the normal person here. So here we need another testing part. So we need, if the results are not up to our expectations, we need to go back and we need to train the model again. So that training of the retraining of the model varies from discipline to discipline and domain to domain. The domains where data is uh, being changed or is changing day on day basis, we need to train the models on the basis of day on day. And the problem and the areas where the models are being utilized and they need and the data remains consistent over the couple of months, so we need to train the models after sometimes, maybe after 3 months, maybe after 6 months, maybe after a year. That depends. So based on that, the whole process of modeling and data science would require 10 steps, starting from acquiring the problem to delivering the results. Now let's talk about AI. Uh, in very layman terms, we can say that AI is a very rapid uh, automation of all that process. What we have been doing over here, we have been manually selecting the attributes that okay, this attribute should be we think that this attribute is very important, or we think that this attribute is not that important, just discard it. AI would help us, and deep learning would help us to do that work what we were doing manually. Like we were selecting manual variables, we were selecting the manual combinations of all those attributes. So AI would help us to, in order to identify that okay, this variable is important. Let's just make a unique combination of this variable with all of the variables. Let's just multiply it with all of them. Let's just divide it with all of them. Let's just make the factorials of all of them. So a lot of combinations will be made, which we were manually making over here. Maybe we were able to identify 100 or 200 variables. Deep learning algorithms can enable us to make unique 1 million or 2 million or 3 million parameters instead of those 120 KPIs. So that's a hell of a difference between both of them. So based on the difference between both of them, we can safely pitch the deep learning to any client or any business user. Okay, there's a problem in that as well. So while analyzing and while uh, identifying the variables and explaining those variables to the business, that's is very easy in conventional machine learning, because you have 120 or 80 parameters where you are specifying the importance of those variables and you are delivering that. But in deep learning you have some variables which are very hard to explain, which are very hard to even analyze or visualize. So that's a problem for deep learning part, but it's way more accurate as compared to your conventional models. So we are done with the slide. Let me just go through the question answer part if we have any question. All right, guys, if anybody has any question, please raise your hand so that I can like mute you. Till here, we don't have any question.
We
Yes.
do have a question in the chat section as well. You may check after taking Akib's question.
Sure. Yeah. Okay, do you have any question?
Yeah, Albab sir, I have a question that when we built or train a model, then we validate it. So it's like you are validating it with the test set, right?
We specify a separate part for the testing, for the validation part, and we validate it with that particular part, and that particular part is not being fed into the model before.
There are two methods, right? When we have uh, mm, fold testing, k-fold testing, like we have like uh, different types of testing. Like when we train a model, we will use 70% or 80% of data, and we will spare 20 or 30% of data for the test set. Yeah,
Yeah.
that's one method, and the other one is validation method, in which we are randomly choosing 10%, then 10% of other other data, then 10% of other data to validate and train that. So which one we are talking here?
We are talking about look. Okay, let me tell you. Uh, when you're targeting a validation set and you think that it's related to k-fold validation, yeah, you can say that that's another sort of validation which we do usually do. But over here, the validation part is whenever you train a model, you specify some of the part for training. Let's just say that's 80%. You specify some of the part for testing. Let's just say that 20%. I'm talking about that 20% right now. If that 20% data is available and you test your model on that 20% data, that's the validation part. All right. In
Okay,
most
I
of the
get it.
cases, people do that they train the models on 80% of the data, and they target that 20% data and they make two separate cuts out of that. They validate on 10% and they test on 10% again. You get it? So there's another rule that validation set and testing set should always be equivalent to like judge the performance of the model. Do you get it now?
Yeah, I get it. Another one. Can I have
Yeah.
another one? Yes. So we are talking about this. Uh, in our exploratory data analysis, we will like EDA. We will choose features which are more important than the other ones.
Exactly.
So we are doing it. Yeah, yeah. Uh, we will see that if we will use all the data and we train the model, it will get a better accuracy. Are we choosing a best feature set and then we will have a training on that feature set on the selected feature set and we will have a better accuracy. So it's all we are doing it all in exploratory data analysis, or we can have like feature importance method in bagging, like bagging. So in which we first train the model, then we will check whether which features are more important and which features are not like more important. So my question is, are we doing in EDA that part in EDA or after training it, training that model?
Okay, so there are two main parts. Akib, I guess Akib is asking this question. So Akib, there are two main parts. One of them is exploratory data analysis before going into the models. Like I'm specifying before going into the models, we explore the data first of all, and that exploration comes to decide whether the data is correct or not before going to the model. The variable importance part
Yeah.
comes that, okay, once you had selected the data set and once you had selected the list of KPIs, out of those KPIs and out of those variables, which were used in order to help the model to classify between both of the classes, all right? Or you can say in order to use the or detect anything, or you can recognize anything, stuff like that, you know. So that helps us
Right.
to identify to solve the problem with the help of the model. That is the variable importance, which comes by default with every model. Every model gives a variable
Okay.
importance. You can
Yeah, yeah, yeah.
go through random forest or any other like that. So I'll briefly move to the comment section.
Right.
I have a question from Sakib Yakub. The question is, what about something like condition which does not belong to any team, to both teams, depending on which way you want to look at it? What do you do with the data about the pitch condition or say weather condition? Sakib, can you please turn on your mic so that we can get to know about what you're saying? Yeah.
Hi, morning.
Hi, Sakib. Hi,
I
Sakib.
just
I can hear
wanted to know, because you gave the example of the two teams and you're taking data for one team and the other team. So I
you.
was
Yeah,
just asking, just thinking about it in a general way, what would you do with data that belongs to both teams? How does that factor in to that analogy that
all
you
right.
gave?
Okay, that's a question. Okay, that's a very nice question, by the way. Regarding the pitch conditions, which doesn't belong to any team. So what we do is that we try to make the groups for that pitch. We try to identify that, okay, on this particular pitch, if team A had been playing, how many times it had been winning. If team B was playing, how many times it had been winning. And based on that, apart from that, also the weather conditions would plug in, and we can like make the decision on both of them that, okay, whenever the weather is very humid, team A doesn't win very often. Or whenever the uh, weather is very hot, team B doesn't win very often. So based on these sort of conditions, we make some rules. We make these sort of rules that, okay, if the weather condition is hot, if the pitch is very dry, team A wins. If the weather is very humid or pitch is not very not very dry, so team B wins. So we make some rules like that. We make the rules one attribute after the other attribute, so it works like that.
Okay, thank you. Yeah.
Nikhil Jaha is asking about how to deploy model which does not run every time we provide input, but just produce results. Like once trained, it only used to producing results. Okay, Nikhil, so basically your question is related to deployment of the model. Okay, so the model deployment is topic where we specify the scheduling of the model. So for example, if you have trained a model once and you need it on daily basis, so we need to schedule that script of the model, whether that model is on AWS SageMaker or that model is ingested into any any tabular data warehouse where you are using Teradata or you're using any other MySQL server. So you need to specify a script. You need to use the in-database scoring of those data warehouses where you'll integrate your script into the running scheduled commands, where you need to integrate your model or your model file to that particular data, where the data would be populating on a daily basis or the data is populating on the monthly basis or weekly basis, whatever the time window is. So you need to schedule your models on that, and you need to schedule your models by making a PMLs for that, or you can use Flask for that as well. Moving to the next question, I guess it's from Ali Hassan. What is the size of 80% required? How many samples are usually considered mandatory? Ali, that's a very nice question. Basically, whenever you target a problem, we try to first, in the initial runs, we try to keep the natural distribution of the problem. For example, I am trying to identify a threat, and the threat is only 5% out of 95% normal people. So I need to first train a model to check the sampling distribution of 95 to 5%. If the results are not good, so what I do is that I start decreasing or start increasing the potential threat which I need to identify, and decrease that number of normal customers in order to give more and more data to my model to understand the relationship between both of them, or to classify between both of them. So in that particular situation, I start decreasing the number of samples of one class and start increasing the samples of the other class. So basically, I start doing upsampling on my target class or my target positive class. Amar has another question. As we know, there are multiple ways to validate the model, but on the basis of we have to decide that our model is best fit. One is precision. Okay. Yeah, Amar, basically, yeah, you're absolutely right. We have various set of criteria, whether we need to go into the precision or recall or accuracy. But the problem comes when we the performance criteria is partially based on the problem statement. For example, if you are solving a problem where you are trying to identify any potential threat, or any person who is affecting your business by selling any false product. So you need to identify all of those people who are selling or who are making any false sales in your particular product, particular bucket. So in that particular situation, what you need to do is that you need to look into the recall part or the coverage part. But there is a weighted average of both of these, precision and as well as recall, which specify that whether precision is good or recall is good, and based on that, the weighted average tells you that okay, what is the absolute change of that model whenever you tweak any of the hyperparameters, and that is F1 score. All right. So your answer is F1 score for that particular. Okay, let's move to the next slide. Okay, right. So if anybody has any question till here, you can raise your hand. I'll be answering that. Otherwise, I'm moving to the next slide. Right, guys. I guess nobody has any question till here. Okay, let's move to the next part. So here, whenever we talk about AI, okay, whenever we talk about AI, so AI almost covers every perspective and every field around us. If you talk about CCTV, cameras, if you talk about self-driving automated cars, if you talk about robotic automations, you talk about industrial advancements, you talk cell site level hierarchies, you talk about smartphones or your laptops or PCs or uh, any sort of home automation, or even talking about the industries and grocery stores, you can see you will come across every sort of AI there. That AI varies from a simple condition of group I to a very complex reinforcement model as well. So all of them comes under the umbrella of AI. So if I am in automobile industry and I'm working on such complex models where I have to decide whether uh, on what particular path my car should move, whether if any object comes in front of the car, what sort of reinforcement learning I need to implement, comes under the umbrella of AI. Similarly, if I am providing a particular product to my customer, which is best suited as per his demands, that's an AI. If I am talking about uh, automating my home as per my desires, as per my expectations, that whenever there's a morning, I need to lift my curtains or anything like that, or I need to turn on the heaters, or I need to turn on the air conditioners. So that all comes under the umbrella of AI. All right. So automating any process or making a rule for any manual work, that comes under the umbrella of AI. So whenever you think about AI, most of the people out there think of like it's something like what's being shown on the screen, but actually it's not like that. Actually, you think, or you intuitively think like that AI would be somewhat, if I develop AI, or if I develop any solution to a problem, it would look something like that, or I would be making somewhat like this Arnon types machine. But actually, AI deals with complex mathematical equations. It deals with a lot of nodes, and the decision of the variables, and it deals with the integrations and derivatives, and everything comes under this particular this umbrella, this AI part, where you are defining the back propagations, you are defining and you are making the predictions more and more correct, and you are trying to minimize the error of all of your problems and all of your models who are making a solution for your problem. So it all comes under the under this AI part. So briefly going into the detail of ML, and then comparing it with deep learning. uh, Machine learning is divided into four main parts. One of them is experience, where you see, where you get the information, and where you get all of the experience from that data, and the data and the experience related to that data. For example, if I say that I am 4 years of experience, so it means that I have been working in any organization solving different sort of problems for the couple of 4 years. In machine learning or in deep learning, the experience comes from that data. More and more data generated gives more and more experience to my model or my algorithm. So it is it's actually able to make a very complex equation or line based on more and more data. Massive amount of data comes, massive amount of, on the massive level, my equation or my mathematical formula varies and tweaks itself to give me this output. So that comes and that tells us about the training. Once all of these three processes are done based on the experience coming from the data, model has been trained, we look into the trends and we look into the predictions. Both of them give us the output that, okay, this particular model was giving this accuracy or this precision or this recall or this error, this sum of squared of error, any parameter can be there. And that prediction is actually telling us the output that, okay, based on the data and based on the truth set, what we gave to the model, this is the output. Coming to the discussion of deep learning, that was ML, what we discussed in the previous slide. In this particular slide, deep learning came into existence from early 1950s. Early 1950s, in that particular situation, at that time, making any programming code to solve a problem, simple problem, complex problem, any sort of problem, making any code was considered as the part of AI. You can say early artificial intelligence was, AI was very exciting at that time. Till 1980s, ML started flourishing, where we started capturing lots and lots of data, and that data was being fed into any mathematical equation. That can be y is equal to mx plus c, that can be a straight line equation or 2-point equation. Based on that, we started looking into the mathematical outputs, and we started looking into the solutions with which basically maths was giving us based on that data to form the output. But right after 2010s, deep learning started flourishing. Based on all of those basics, what we had made back in AI and back in ML, we have flourished and we have converted that variables and that whole platforms into very complex platforms now. And that is defining that, okay, now there are complex CNNs, there are LSTMs, there are reinforcements learning, there are GANs who are helping us out to get the good results which ML wasn't able to give us. So there are primarily two parts where we can differentiate between machine learning and deep learning. One is the automation. You are actually automating each and every script of machine learning into a whole automated process. So in order to keep yourself away from that manual work, what you are doing in machine learning. And secondly, you are going to make things more accurate as compared to the past. So these are the two parts where deep learning and AI is helping us. Okay, so do we have any question here, guys? Okay, I'm coming to. Okay, Dr. Mohammed Salim Iqbal, your question first.
Sir, thank you very much. I am very much enjoying your presentation. I want to ask, sir, what is the role of artificial intelligence in medical profession?
Okay. Any other question?
And please elaborate further about artificial intelligence and machine learning and deep learning.
Okay, sure.
Thank you.
Answering your question first. Salim, basically, in medical imaging or medical field, there are numerous applications of deep learning, machine learning, and AI, all of them. Starting from looking into the neurosciences, you would be coming across machines deciding on their own the type of the problem a particular patient is facing. Similarly, looking into the diabetic retinopathy, looking into the different disease identifications based on ML and DL. Okay, for example, let me give you an example. Uh, it's a very exciting application. For example, 10 years back or 8 years back, you were identifying the blood pressure of a particular person through a manual, apparatus. You get it? You try to pump the air around the vessels of your particular body part, and then you try to monitor the blood pressure manually. These days, it is being done on digital level. It's basically the application of machine learning. So each and every pulse is being fed into the model, and model has learned the rule, and now it gives you the output on the basis of those sensors. All right, so that's the application of ML. Similarly, in order to identify any problem through non-invasive way, where you need to take out the blood or you need to take out any liquid from the body part, and manually deciding the output for that body part based on the tests, what you can do is that you can simply label the data. For example, I need to identify whether I am anemic person or not. So based on that, what you can do is that you can simply take the pictures of my body or my body parts, who basically makes a difference whenever you are anemic or not. All right, or whenever you are facing any problem. For example, let's just talk about glaucoma, or let's just talk about cataract. If you have any problem like that, you can simply fit those images to the model along with normal images, and model can decide that, okay, this patient is cataract or not, this patient is normal or not, and based on both of those applications, you can give a very good relief to a doctor. You get it now? Muhammad Salim Iqbal, am I able to answer your question?
Sir, so nice of you. I am highly obliged. You have explained very well. Thank you.
Thank you so much. Okay, so we have another question from Janakan. Hi, Janakan. You have a question.
Yeah, awesome. Thank you. So, like you were saying, like now everything has been updating to deep learning, but there are still some kind of data sets, right? Tabular data sets are not that much developed in deep learning, because like I do my research in kind of a tabular data side, kind of creating neural networks for neural networks for tabular data. So can you talk a bit on that as well? So if you don't mind.
Yeah, sure. Janakan, basically, in deep learning, we specify some of the data sets. For example, we work on videos, we work on images, we work on unstructured data to convert them into a structured form. Once we are done with all these parts, now we come to the tabular part. In tabular data, for example, if I have a question and the question is to solve a particular problem, and the problem is to make a propensity model, for example. In the propensity model, for those who don't know about propensity models, so those are the sort of models where you identify a customer or you identify a person whom you should give a particular product. All right. You find the propensity of a particular person to pitch anything. All right. Based on that, this comes from the tabular data. For example, you have the data of subscriptions, or you can say day-on-day activity of that particular person, or on anything like that. All those data points are fed into a neural network. Currently, at the moment, what you would be doing is you must be doing, and that would be, you would be making a artificial neural network connected with some fully connected layers. All right, having some nodes. What we do is that we give those data points to our models. Those can be CNN based, convolutional networks based, and those internally in those CNNs, we start making the combinations of those KPIs or those tabular columns. So basically, whenever you try to feed those columns to your neural network, you try to give the number of dimensions, or you try to give the number of variables to the model. And based on that, you try to expand your network and try to generate more insights out of that. That can lead sometimes that can lead to overfitting as well. But in most of the cases, in most of the general cases, it works really well. And you need to then first you need to expand the network, and then you need to converge the network, and then the network gives you the output. Tabular data can be used for neural networks, can be used for time series based LSTM models, can be used for CNNs, can be used for reinforcement, all of them. Yeah, they can be used as well as GANs.
Yeah, but the thing is like when considering tabular data, will they be working for CNNs as well? Because like convolution were developed mainly for image kind of data set, isn't it something?
They have been made for image kind of data set primarily, but they can be used for tabular data as well. We can use it for them as well.
Thank you, sir. That was like, thank you.
Okay. I have a question from Amar Sayed. Okay, Amar, can you please turn on your mic so that we can? Okay.
Assalamu alaikum, sir.
Hi, Amar.
So my question is that which type of data we have to take decision that we have to move from machine learning to deep learning. Like there is a huge amount of computational cost of deep learning models. So whenever we have to make decision, we have to move toward deep learning rather than to be on machine learning.
Okay, Amar, you will get your answer for this particular question in my upcoming slide. Everybody would be enjoying that. So I have a whole scenario based on that when you need deep learning and when you need machine learning. So that will be covered. Okay.
Sure.
How to choose the number of nodes in the layers? Yeah. Others, I have read your question. Your question will also be catered in the upcoming slides, correct? So, okay, let's move forward for now. I am not sure how much time do we have. Okay, we have 1 hour. Right. Okay, let's move forward. All right, guys, we are having lots and lots of data being populated right now. In the last 1 minute, when we were talking about these questions, so Facebook was able to give us around 0.24 million photos in 1 minute. In the very similar way, Google was able to acquired the data of 3.8 million searches on Google at the moment. In this very similar way, Skype was able to handle around 2 million of minutes in the last 1 minute. In the similar way, Netflix had around 87,000 of hours of videos watched already while we were talking about these questions. So it means a massive amount of data is being populated on, on the basis of the last few minutes when we were talking about our problems. So these days, Zoom is also in the market. So based on that, it means we are generating lots and lots of data on the daily basis. All right, you can say on the monthly basis, on the weekly basis as well. Even you can say on the hourly basis as well. It means that if the data is being generated on a massive scale, so it means we need to have massive computational power for that to gather that amount of data. For example, now let's just say, for the sake of argument, we say that we already have that computational power and we can gather that much amount of data which is being generated on this hourly trend. So it means that when more and more and lots of data is being populated, it means complex problems are being generated on daily basis. So it means problems have now evolved from a simpler ones to a complex one. So it means that our skill set also needs to be polished. So we need to move from simple models to very complex models. So for that particular situation, Now let's talk about that. Now let's talk about this slide here. On the basis of the data, however, on the x-axis, you see the amount of data is increasing. So in some particular situations, when the data was not at bigger, machine learning models were giving you good output and they were rising in the performance. But after some time, when the amount of data started growing massively, machine learning models somewhere around started giving us the constant output. It means that they weren't flourishing to give us the output, right output. So the amount of data was increasing. Ideally, we needed the performance to be increased at the same time. ML models weren't helping us out, weren't enabling us out to. So that's why we had to shift ourselves to machine deep learning. And in that particular situation, you can see the red line is giving us the absolute increase and a good exponential growth in the performance when the data is also rapidly increasing. So if I talk about, you have a tabular data for like around 5,000 to 10,000 number of rows, so it's good to go. You can like train the model and you can get the output. But if I talk about, you have billions of transactions on a daily basis, and you need to train the model on billions of transactions on tabular data. So you need to move from that machine learning part to deep learning. Get it now, guys? So the performance increases with the help of deep learning when the data is also increasing. Guys, I would suggest to please mute your mics. Right. Thank you. So the performance increases with the help of deep learning models as compared to machine learning models, and uh, ultimately solving our problems when the data is also increased. So now let's dive deep into deep dive into the deep learning analogy. I hope Amar was asking the question that when to use the deep learning model and when to use the machine learning model. So that's a clear boundary. Whenever your data is exponentially growing, so you need to implement DL models instead of going for classification or basic classical machine learning models. Talking about deep learning analogy, so it's basically derived from a human brain. So human brain is actually uh, based on the neurons. So the idea of the neuron is being replicated to a mathematical equation. So for example, whenever, let's talk about that in detail, how that works. We talk about a deep learning analogy based on a particular neuron. So what the neuron does is, it has some, you can say in layman terms, you can say that we have some of the sensors over here which collect the information from all the body, and it sends that information. Those are basically collected through dendrites. We call them dendrites. If you collect the data from those dendrites, they send that to the central nervous system, and that decides that, okay, what action needs to be performed. And based on that, we have a layer which is going to the output, and it gives us the output that, okay, based on this nucleus and based on the processing of this nucleus, the output should be either this or that, and that's carried out with the help of exon. So replicating that with the help of mathematical equation over here on the right side, you can see we have some v's, v1, v2, vn2, vn minus 1. So these are those sensors which give us the input, and those inputs are categorized. Okay, what sort of input is important, what is not, and those inputs and those importance of the inputs are being labeled with the help of these w's, w1, w2, wn minus 1. These are actually weights. So whenever the weight is very high, so it means that input is giving the high importance, and whenever the weight is low, so it means the input is not having very much importance. So the combination of all of them over here, over in nucleus, in your central nervous system, where you were deciding, we are taking the help of a deep learning engine to categorize it into a whether class A or class B. That okay, we can say that whatever the output needs to be generated, that is being done over here. So we are actually replicating a nucleus, or you can say a human neuron to a mathematical neuron. So we have a question again, I guess. So Rob, if you have any question, you can just type it over here if your mic is not working. Okay, let's move forward. So do we have any question?
What about the bias?
So bias is always there. So basically, in this particular problem, in order to explain the overall working of a overall conversion of a biological neuron to mathematical neuron, we have assumed that right over here no bias is included, but actually in every deep learning model there is a bias included. But here, for the sake of understanding only, to replicate the model, we have excluded that.
Thank you, sir. But I have a doubt. So, if the
Yeah.
do we have to decide the bias, or the bias has to be something which is every time it is kind of, how to say, constant or something? But it changes for a particular neural network, right? Isn't it something like that?
Okay, let me answer that. I'm sorry, I missed your name. Okay, Janakan. So basically, Janakan, bias is always one. The thing which changes with respect to every model is the weight associated with that bias. The value for bias is always taken as one, all right? But there is also a weight associated with that bias. For example, here would be another input, and that input is one. But again, that input also has a weight, and that weight is W. You can say Wn plus 1. That weight varies on every node, varies on every iteration as well. All right, that changes itself on every iteration. Whenever you go forward, whenever you try to come back and reduce the error and try to solve try to fill the gap of the error, try to minimize the error, try to decrease the misclassification rate in your models. So for that particular situation, you need that weight to be there, associated with the bias. Yes. Muhammad Ismail, you have a question that we need to directly jump to DL. We need to actually DL is a modified version of ML. So we need to go through ML every time in order to understand where DL can help us, deep learning can help us, and how it can replace machine learning. So without having a good information about machine learning or the baseline models, you cannot make a a cherry on the top for that. Okay, so Rob, have a question that we need to know about the bias, and will there be any range of value for weights? Yeah, so basically, guys, whenever you incorporate a bias in your model, so its value is generally used as 1. But the weight associated with that is fed with the help of a uniform range of weights, which are basically very close to 0. We need to have a normalized set of uniform weights, and those weights are being tweaked on every iteration on the back propagation. Whenever we discuss the concept of back propagation, we tweak those weights. We tweak those weights with the help of error E generated at the end of the output, at the end of the network. Based on that error E, each and every weight of your model, if you have, let's suppose, 10 layers, so it means on 5 weights on each layer would make around 50 weights. So those 50 weights will try to optimize themselves based on that error E. Okay. So right over here in this equation, you can say there are a lot of lines. You can see there on from input layer 1, from input layer to hidden layer 1, hidden layer 2, output layer. So it means that on output layer, we have some dedicated output, which needs to be classified, whether it's being classified into class A or class B. If it's classified into class A, but actually it belonged to class B. So it means a error was generated at output. So that error needs to be decreased, and each and every weight over here, you can see more than 50 weights are over here. On every line represents a weight. These weights are actually the node and the line, both of the combination becomes the multiplication of that node value and the weight, or you can say the input and the weight. The combination of both of them will generate the output over here, and that output will go in the next layer. Of course, there are some of the activation functions which are there to help to normalize the outputs. You can say those activation functions are ReLU activation functions are there, sigmoid activation functions are there, leaky ReLU are there. They all depend, all vary from problem to problem. That okay, if I'm dealing with images, so I need to look into ReLU activation functions. If I'm dealing with tabular data, so I need to look into sigmoid activation functions, or that varies with the help of your domain knowledge. But the inputs and the biases, all of them are fed into the models or your layers along with the help of these weights, and these weights are peaked whenever you go to the you go into the backward propagation. So that's being done over here. Okay. So Rob, yeah, you are right. In order to find the optimized weights, you need to drop the error. Right. Zahid Ahmed has a question. Let me see. Okay, Zahid, you can like ask your question now.
Assalamualaikum, sir.
Hi, Zahid. Assalamualaikum.
Sir, I want to ask a question regarding a data set of images. That how can we create the labeled data set of images? And another question is that if I am detecting a disease of like some plants, and I'm taking a close shot of any plant, then it is able, my model is able to detect the disease. But if I'm taking a drone shot from like you can say from 15 to 20 meters, then my model is unable to detect the disease. So how can I solve this problem?
Zed, first of all, your question was referred to the labeling of the data set. All right, in order to make any model, first of all, you have to, sorry, you're saying something? Sorry. Okay,
no,
so that in order to label the data, first of all, for any problem, if data needs to be labeled on the first place, there are two approaches. One of them is you specify, let's suppose 500,000 images, and you label them manually. There is one approach. There's another approach, which is semi-supervised approach. Semi-supervised approach is that you lock 100 or 200 labels, all right? You label them manually, and you train a very baseline model for that. Based on that baseline model, what you do is that you start classifying some of the images from your data set on which you are 100% sure that these are correct. Based on that, ones and zeros or whatever the classes are. For example, you have 5 different classes of the problems of your plants. So if your model starts giving you the output which is accurate one on those smaller set of chunks, so you need to go to the bigger level step by step. You need to label first, you need to train the model on that, specify some testing set, try to score that on a bigger set, maybe 100 more or 500 more, try to classify them, look into the results. If they are correct, combine the data. and then move to the bigger one. And in that particular situation, if you have no labeled data set, you can go like that. And the other option is that you have to manually label 500 to 1000 images, and based on that, train the model and then score the whole of the base. Coming to the second question was that if you have a very HDR sort of image of your plant, you are able to classify the image. But if you take the image from a satellite, so it generates a problem. That would of course generate a problem because the quality of the pixels which had the information previously was way too big as compared to the satellite image. Satellite image won't have that much amount of information what was required when your rule was being made. Your rule was being made on the number of values of the pixels which were highly classifying both of the classes in a very complex model. But now you are giving a generalized image and it's giving you error. So for that particular situation, either you need to discard the satellite images, or if satellite images need to be in the picture, so you need to modify the data for satellite images only, and you need to train the model for satellite data only.
Okay, sir. Sir, I have another question. Like your telco industry using CRM, right? So CRM is able to predict the churn of a customer. So if CRM and some other SAP tools like SAP, they are able to predict customer churn, and they are able to predict the recommendation and which customer is going to do what in future. So why we need to use deep learning? Can you please explain this? So how can we use deep learning to modify that? Or
Okay, so let me explain. In our telecom industry, if anybody else is from telecom as well, so conventional machine learning models help us to identify the bases who will churn or who will not. All right, but deep learning help us out to make the decisions more accurate as compared to the previous ones. To make the decisions more accurate with respect to the recommendation part, because if you compare a priori algorithm or FP growth algorithm with the deep learning algorithm, so that's a way to difference between both of them. All right, so in order to do that, in order to make the processes automate, yes, in order to make more accurate decisions, we have to lift ourselves towards deep learning.
thank you, sir.
Okay. I have a question from Hitesh Swani. If you want to do a prediction using ANN, how does that happen? And why should we prefer deep learning or machine learning models in prediction? All right. Hitesh, basically, whenever you're using any ANN, so basically what you need to do is that you need to make a model. You need to make a score file of the model, which has all the rule of the model. Whenever you train a model, I hope you would be training a model of ANN. Once you are done with that, you make a package for that. You when you are trying to make the prediction for that data, so you need to get a new data having all of the same transformations and apply that to your model, pass that through your model, and it will generate some probabilities, the probability to fall in a particular category. That probability is used to make a new class or to generate a new class. All right, and that class would be with whatever you had fed while training the model. Based on that, predictions generate. You know, there's a, you can say in conventional machine learning there is a function named as predict underscore classes, so that is being done over here. Based on that, what you need to do is that you need to log that predictions and compare them with the actual outputs. Second question was, why should you prefer deep learning? We should always prefer deep learning to machine learning models, because machine learning models help us out to make a pipeline, just a pipeline to make the things run. All right. If you need to be accurate on those pipelines, that okay, when the new data is coming and the extensive and heavy data is coming and the prediction should not give any error, So we need to implement deep learning every time whenever we need to make right decisions. Okay, guys, we have a lot of questions and my slide deck is missing. Okay, Janakan, yeah.
Sorry, sir. Sorry to ask
Yeah,
so many
sure,
questions.
sure.
Like you were, it's a kind of a follow-up question about like what the before guy asked. Is it something what you said was something like related to a transfer learning, because you use a different model and use it for a different kind of data set? Is it something related to a transfer learning or something? Can we call it as?
Exactly. Whenever, Janakan, you try to implement any image, try to implement a model which is somewhere already implemented in the industry, or anybody in the research or academia has already implemented that model, you can opt transfer learning for that. But if a problem is very unique, so I won't recommend a transfer learning model. In order, you can use that transfer learning model to start a baseline model from that. All right. So by looking into the weights of that model or fine tuning that particular model, you can do that. But it's always good to have an architecture of somebody else to train your models to solve your problem. So yeah, that can be done.
Okay, thank you, sir. And just one question. So you earlier you said like we can automate the categories. I mean the variables. Each variables. If there is 100 column in a data set, like deep learning automatically captures which 100 column is needed. But don't we do it in a pre-processing stage? We just take, okay, what we assume these variables will be the important, and then so won't the deep learning will be automatically understanding in the 100, the 10, which the most prominent 10? Does deep learning has any facility, something like that? Was just
Deep learning models, basically, what you're saying is that in the you are basically, I guess, confusing it with the machine learning part. In machine learning, you first go into the pre-processing part and you specify the important 100 variables. In deep learning, what you have to do is that you need to dump all the variables into the model, and the architecture of the model, architecture of your neural network would decide that, okay, which particular uh, feature. In deep learning, the word is not feature, the word is feature map. Which feature map is the best one, and with what is deciding that, okay, this should be the class or this should be the class. Based on that, we decide whether this feature map is the best one on what particular layer. For example, if I go back, you see my slide. For example, you see I have two hidden layers over here. All the data being created over here in deep learning, in CNNs, it's a feature map. It has its own dimension. These number of feature maps decide, okay, you can decide yourself, everybody over here. Over here, I had three inputs. There were three variables, three attributes were there, on the basis of which I needed to decide whether the output should be class 1 or it should be class 0. All right, team A would win or team B would win based on three attributes. Just observe yourselves that, okay, whether that decision should be correct if I decide on the basis of these three only, if I decide on the basis of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12, 24, and 4, 28. Whether I can decide on the basis of these three attributes only or these 28 attributes only. So the comparison is right in front of you guys. Right over here, I'm deciding on the basis of 28 different attributes. And over here, I'm deciding on the basis of only three attributes. So it always gives us more and good output over here. All right, guys, I'll quickly go through some of the slides in the major revolutions of IT back in 1960s and 1980s and 1990s. There were PCs were there. Then smart home automation started coming into existence, and then smartphones started coming into existence. What was the major revolution in IT? And now, currently at the moment, deep learning is the next best thing which is happening these days, and everybody is like working in it. There are various applications of the deep learning over here. One of them is predictive analytics, which is the major part of deep learning, machine learning. One of them is predictive analytics, and the other one is deep learning. Similarly, in speech part, we are working in text to speech, and we are working on speech to text. We have various applications for that. Whenever you type something, we have applications which convert that text into a speech. That's a application of deep learning. Same goes for vice versa in the speech as well. When whatever you speak, that converts into a text. Similarly, it is into vision, where we are working in machine vision. We are building applications for image recognition, where face recognitions and potential identifications of threats are all the applications for that. Now we have a lot of applications in NLP. So natural language processing has a scope these days where we are getting loads and loads of raw data, unstructured data, and converting that data into a structured form. By that means I'm referring that we have loads and loads of text. You can say we have a raw text of just like an essay, and I need to specify and I need to identify the locations or cities or time or the names of the people out of that data and dump that into a tabular data. That's done with the help of NLP, where we see that we are targeting data extraction over there. Similarly, based on that data extraction, we are also implementing classification models, and we are translating that whole text into another language. So translation is being done, data extraction is being done, and classification is being done. So in order to implement deep learning, we have expert systems, we have optimization systems, and we have robotics frameworks as well. All of them are there to help us. Okay, so let's move forward. Deep learning applications are always in the automated mobile industry, where we are using the cameras to identify the speed of the next cars, to maintain a specific distance, to avoid any collisions, and to make the right decision at the right time. So you can see somebody of you guys would have learned about or heard about reinforcement learning. So that is all incorporated in the machine vision at these ages. Similarly, we have speech recognition, which is also in the market these days, where we are fetching the information, trying to identify who was the speaker, trying to identify what was the noise, what was it related to, who was the author or the owner of that particular voice. So all is that being done with the help of speech recognition. Apart from that, in NLP, we are making very intelligent chatbots who are able to assist all the customers globally or worldwide for their particular problems. So in order to solve that, we have generated NLP-based chatbots over with the help of deep learning models, where we have been using RASA, and we have been using LSTMs to help these chatbots to work. So basically, it's another concept in the deep learning where we work on that. Next is a very interesting application named as image captioning. I would have the question and answer session at the end of the slides, because I have a long list of slide deck which is remaining. So I need to first quickly go through all of that, and then we'll start the question answer session. Image captioning is another concept in deep learning where we generate the stories out of the images. Based on the image, we generate a whole caption, what usually people do on the social media these days. So these are some of the applications on your screen that, okay, based on first image number A, we are identifying that, okay, a man in a black shirt is playing a guitar. So basically the guitar is there, black shirt is there, and a man is there. So combining all of them, deep learning model is able to generate a whole sequence or generate the whole story out of it. Similarly, in the second image as well, the output, what comes from the machine is construction worker is in the orange safety vest working on the road. It's coming from the machine and in the third as well. So apart from that, medical imaging is is utilizing deep learning models to identify the cancer and to identify the various different images. Guys, please give me a moment. All right, guys. Sorry for the break. Okay, so deep learning has tremendous applications in cancer prediction, where we are helping doctors to enable them to identify cancer on early stages. Apart from that, uh, identifying the type of a particular cancer, where you can see that, okay, these three images, based on these three images, four images, we are able to identify that, okay, from deep learning and looking into the every possible angle of that particular cancer, we are able to identify what particular type of cancer is this, and how will it evolve, and where it will affect the human body. So it's a tremendous application, and the work is consistently going on in this field. Apart from that, I already have mentioned about machine vision, where we are working in uh, uh, automated mobile industry, in order to specify and target the paths where we are trying to move our cars towards, and how to optimally select a route for your to reach at your destiny. So that's being done in machine vision as well. So machine translation is another application which I have briefly described before, that based on any sort of input, you train a deep learning model, and it will give you the output into your desired language. So whatever the input is coming from any language, you can convert that into your, based on the dictionary what you have made in your deep learning engine, and based on that, it will give you the exact output what you want. So pose generation is another application where deep learning models are helping to identify the poses of all the players playing on the field, to capture the real-time data for those players, and to assist them into the future. What possible mistakes could they make during their postures, and what possible areas are where they can work. So that's another part. Neural style transfer is a very nice application where most of our youth is excited about to convolve the images, whatever the filters you guys use on Snapchat, on Instagram, on any filter, any social media app. So in order to beautify yourselves, in order to make yourselves very interesting, so basically you convolve the images or you convolve the filters. Right over here we have an image of a person. So this image is basically being convolved with the particular image, or that can be a filter as well. So convolving both of them, or you can say uh, matching both of them, you can generate an output right over here, what you can see right in front of you guys. This output is the application of that particular filter, what you have applied. So there's another application which is being seen in the deep learning. Apart from that, music generation is another application in deep learning where you guys can generate any music which is unique and as per the taste of your genre, both of them. So you can generate a music for your own self or for the sake of or the sake of entertainment. You can generate that. So that's also being done in the machine learning, deep learning. So there are two faces right in front of this slide deck. So deep learning is enabling people to generate the faces as well. Both of these faces are being generated by machines, by deep learning models. So these are not real images. So, but you can see the clarity and the realness of these images generated by deep learning models is way too exciting, is way too unrealistic, because you can see the number of features through which the model is generating the output over here is right in front of you guys. So both of them are generated through faces. Faces are generated through deep learning models. Apart from that, deep learning is helping us out in precision medicine. It's helping to restore the sound in the videos, to uh, transcript the text from the lip movement of any person. So based on the data fed into a particular model of the lip movement and giving the output for that particular transcript, machine is able to identify, and deep learning models are able to classify all the outputs like that. Yes, please wait for a second. Okay, guys, so basically coming back, and image enhancement and pixel restoration from OCRs is another application of deep learning where we are enabling our current systems to restore the pixel values which are distorted, to enhance an image, and to uh, identify the data or the desired text from any image which we scan basically. So basically, deep learning is going beyond human performance level, because the amount of work what we do or what machine learning models do in order to help us out, deep learning is actually going beyond both of them. So the applications are exciting, and it's a very nice application out there. So there is an application of Spotify. Most of you guys would have used that at the back end of Spotify. Deep learning models are utilized again. Based on that, it's the usage of those deep learning models and the deep learning engines that it actually looks into the beats of a particular person, the music taste based on the beats, music taste based on the number of seconds what he uses or he listens to a particular music. So based on that, it is able to give the output that, okay, this person should like this person should like this, or this person should recommend we should recommend this particular music to the person, and that's pretty very near to the what would you like. Same goes for Netflix as well. Netflix is also giving the recommendation on like 97% accuracy, and you actually start liking that. So there are some of the industry leaders in deep learning. So Google, Microsoft, and Facebook, all three of them are basically uh, developing the models, are helping and aiding to make and research in these particular models as well. So all of them are using. There are a lot of frameworks in deep learning which we usually use. Most of them are you would have been seeing, like MXNet is there, Cafe2 is there, Theano, Pytorch, CNTK, TensorFlow, Keras, all of them are there. Some of them are developed by Microsoft, some of them are developed by Facebook, and some are developed by Google. So at the end, it depends whether you need a complexity or you need a simplicity. Based on that, you decide whether you need to opt a TensorFlow or Keras, or you need to opt PyTorch. So most of the people work in PyTorch, some of the people work in TensorFlow or Keras as well. Currently, at the moment, is uh, a- uh, Keras is the one on the back end of which TensorFlow is there, and TensorFlow helps us, and Keras helps us to, in order to fetch all the packages of TensorFlow. So in Keras 2, you can directly call all the functions of TensorFlow over here. So tools which are being used in deep learning is again Anaconda, Jupyter, Python, and Spider is also there, which most of the people also use to develop the models. Uh, there are some of the environments in Conda. So in order to use that, I have some of the lists I have made already over here, and GTRIT is here. You can go through that. So you can make a virtual environment and install everything and make the packages there and get the packages, export them, or get them from any list. And you can see what packages you have at the moment to work with that. So we have 150 plus packages over here. And again, GTRIT is also available. All these packages and all these libraries are there to help you guys out to work on whether images, or you can categorical data or numerical data or tabular data, any sort of. So based on that, if you are fetching some data of images or videos, you can use OpenCV for that. If you're using any numerical data, you can use NumPy and Pandas for that particular library. So it depends upon the problem actually. So how do you work? So Jupyter Notebook is there, where a particular user fetches all of the information through the browser. At the back end, it touches the Python notebook and the kernel, which gives a server to that, and that based on that server, you see the output on the with the help of HTTPS and web sockets, you get the output on that the browser and you code on that. So that's one. So in order to install that, you can use the command of conda install Jupyter Notebook in your command prompt. And again, if you need to install notebook conda, so you can conda install NB. So basically, Jupyter is the combination of Julia, Python, and R, all of them. So that's being there. Some of the other packages are there which are helpful. One of them is NumPy, the other one is SciPy, one is Pandas, and the one of them is Matplotlib. These are all the libraries which help us out to identify the problems, and in order to solve and in order to assist us in those particular problems, right? So deep learning frameworks, there are two main frameworks. One of them is Keras and the other one is TensorFlow. Currently at the moment in these days, previously people were using Keras as well as TensorFlow, both of them to classify or solve the problem. But now Keras is the one on which we lock and target all our problems, and it automatically calls TensorFlow at the backend to solve the problems. So there is an interesting book if anybody of you is interested in deep learning. So Deep Learning by Ian Goodfellow is a book where you can get all the concepts and all the information from that. So I guess that's Right, guys, can you guys see my screen? Okay, so there's a book which is very interesting, named as Deep Learning by Ian Goodfellow. You guys follow that. After this webinar, we have upcoming session of Mr. Ali Reza Anjum, and it's about implementation of machine learning without using any code. So basically, you'll be using NIME in that particular webinar, where you will be targeting all the problems of industry, and without using any code, you will be able to solve your problems. So if you guys have any questions now, we have some time to, like 5 minutes, we have 5 minutes to answer the questions of all of you guys. So I'm quickly, you guys can raise your hands if you have any questions so that we can go through yours. So I have a question from Nadia Nazir. Uh, Okay, so Nadia, I have read your question. So basically, there are multiple courses online as well. We at Dice Analytics also are offering a course of deep learning for AI in after 2 weeks. So you can register that in yourself in that. Apart from that, if you want to learn at your own pace, so you can go for Udacity, or you can go for other platforms like Coursera and Udemy, etc. Stuff like that. Sakib, we have a question from you. Slides. Yeah, Sakib, you will be having to. You'll be having the question, the slides, of course, to your email. Zainab and whoever will help you with that. Lata, basically, you are asking for machine learning and artificial intelligence book. If you go through the Ian Goodfellow book, so it's self-explanatory, and it's really good to have that beside you whenever you're working on that. Apart from that, Google is also always your best friend. So any other question? Okay, so we have some of the questions. Dr. Mohammed Salim. Yeah, Dr. You can have the question.
Thank you, sir. Thank you very much for your wonderful and nice presentation. I am highly obliged to you. One thing I want to ask, sir, what is the accuracy of the machine used for artificial intelligence? What we have noticed that as we discussed, blood pressure apparatus, these are not so accurate what we do with manual BP apparatus. So please have a few thoughts about it.
Okay, so basically, whenever you measure your blood pressure, so that was just the sake of an example. So it's somewhere around 95 to 96% accurate, but it gives you the error for around 3 to 4% on every reading. All right, but that error is close to the output. What usually, for example, if you get the output of like 140 by 80, so the digital or the machine learning based apparatuses will give you the output somewhere around 138 to 78, or 142 to 184, somewhat like that. But the percentage of error is like negligible. It's like 2 or 3% at max, not more than that. But there are very good applications out there based on deep learning. When I was specifying about the identification of diabetes or diabetic retinopathy, or identification of glaucoma or cataract or anemia, or you can say epilepsy as well. So based on that, all of those identifications are way too accurate, like around 99% accurate. Those are. Apart from that, some of the applications are also in MRI as well, where the identification of any manual or any problem is definitely being there, where deep learning is helping us out. Yeah, Akib, do you have any question?
Yes, sir, I do have a question, sir. So my question is, you talked about domain knowledge, and you talk about whole thing, like all of the machine learning and deep learning process. So
Yeah.
my question is, do we have to deep dive into domain knowledge and then extract a problem statement and then work on it? I mean to say, you have a
Okay,
process
I get your question. Okay, basically, in order to answer that part, digging deep dive is not the right approach. You need to be one person at your at your end who is the domain level expert. Do you get it? So that from that you'll get the input from the domain knowledge part, but you need to be tech savvy. You need to be very proficient in the code. You need to be very good at mathematics and statistics in order to solve the problems of that particular domain part. We have a question from Amar that how we can work with image data using machine learning models. Amar, working with images on machine learning is comparatively tough one, tough in the sense that you have to extract manual features from the data, and those manual features are the ones which are like standard deviations or the mean values of the pixels. Similarly, you have to see into the medians, and there are a couple of other parameters like HOGs, histogram of gradients, and you have to go through those features as well. So these are some of the questions. Okay, yeah. So guys, you need to be very proficient at working. Hitesh is also asking me about a book. So Hitesh, if you follow this, and Goodfellow book is there. So it's a free one. Comparatively to that, you can also go for PyImage search to get good concepts of deep learning as well, and mathematical part as well. So I guess this is all from my side. Huma, Zainab, are you guys there?
Yes, sir. Okay, so that's all about the webinar. Thank you so much, Mr. Albab Khan. We had a great time on this webinar with you. And
so
to
much.
all the attendees, we have mentioned an email in the chat section. You guys can email us for the recording or any queries regarding our trainings at info@ticeanalytics.pk. Thank you so much, everyone.
Thank you so much, guys. Thank you so much. Take care.
Thank you. Take care. Allah Hafiz.
Hafiz.